Welcome. I'm bjmchugh, and this segment of my presentation concerns a demonstration of the R computing language. Prelude to an R demonstration. On December 15, 2008, the Linux operating system and the R computing language were introduced and demonstrated to Hopewell Valley administrators and to the Educational Program Committee of the Board of Education. On January 11, 2009, introductions were recreated and video was produced. On January 18, 2009, demonstrations were recreated and video was produced. There are many in the community who claim my interests only involve technology issues. It is in my interest to help the school district spend responsibly and show accountability to the community. The amount Hopewell Valley spends on technology is not beneficial, and it is certainly not sustainable. Use of the Linux operating system and the R computing language would drastically reduce expenditures and enrich education. At the January 12, 2009 Board of Education meeting, it was declared that the preliminary 2009-2010 school budget exceeded the state-imposed 4% cap by about $2 million. When Superintendent Thomas Butler, an attendee at my presentation, claimed everything is on the table, one might have believed that all cost-cutting strategies were being considered. Thomas Butler and Robert Colavita claimed implementation of all the strategies now under consideration would still leave the district about $250,000 short of closing the $2 million budget gap. Would they have shown more integrity if they had admitted they only investigated unreasonable and budget inflating strategies? Would the Board of Education claim they were looking out for community interests by accepting such a weak excuse? It is my hope that this recreated presentation will reveal the business practices and fiscal habits of the Hopewell Valley Regional School District. Now to the demonstration of the R computing language. R demonstration outline. Prior to the R demonstration, I will demonstrate the probing of wireless devices with Linux tools. In this presentation, I'll use R to extract and depict wireless information. In later presentations, I'll extract line item budget information, manipulate generic information, create pie charts, generate statistical distributions and demonstrate sampling, define mathematical functions, specify symbols, lines, colors, and fonts, and create two-dimensional and three-dimensional graphs. Prior to probing wireless devices, I'll familiarize the viewers with Linux by showing the following. The user is supplied with and can create desktop icons. I typically launch applications through the Applications menu item. One can access accessories through which a terminal can be opened. One can access various Debian tools. One can access various games. One can access various graphical applications like GIMP. One can access various internet tools like the Iceweasel. One can access OpenOffice productivity suite applications like Base, Calc, Draw, Impress, Math, and Writer. One can access sound and video tools like Sound Recorder and X-Window Video Capture. Through the desktop menu item, one can perform administrative tasks like configuring the network capabilities or setting up printers. And one can define preferences. One can also access online help. Now back to opening a terminal. One accesses the Applications menu item, selects Accessories, then selects Terminal. A terminal opens, but since the wireless tools are available only to the administrator, one must log into the superuser account. The user then issues the command IWList ETH1 scanning, which requests that the wireless tools detect wireless devices. One sees the output. In order to write a file, one uses the same command but points with a greater than sign to an output file, which I call test. If we edit the file with the VI editor, one can read the output file. A listing request shows the file's presence. Wireless coverage. Dennis Schmidt claimed that wireless access is appreciated by HVAC technicians because it saves them from climbing up and down ladders. Dennis Schmidt also claimed that students love wireless access. Information was generated from routers at my home and from wireless access points at GlaxoSmithKline, from Central High School, from Timberlane Middle School and from the administration building. Reading and depicting wireless information with R. Some useful operations are shown below. Here is the script file I wrote to read and depict information collected from the 5 locations. We are interested in signal strength, device name, and signal encryption. The first 2 lines initialize a name vector. These 2 lines define graphical parameters. This line indicates user input for graph creation. This defines the file to be read for each site. This block of instructions is executed for each file. There are 2 operations in the next line. The first scans the file for objects. The second disregards those objects that are empty. The next line extracts the signal strength, the name, and the signal encryption. Essentially, each object is searched for certain characters, for example, ESSID. If found, the characters following this string are extracted. The next line initializes the color vector indicating signal encryption. This line specifies device name placement on the graph. This line defines signal encryption colors. Green is unencrypted, red is encrypted. This line specifies bar plot creation. This line specifies legend creation. I'll typically open 2 terminals and select commands in one terminal to execute in another terminal where R was invoked. One has the option to execute all the commands in a file or selectively execute certain commands. In one terminal, I'll open the R script. In the other terminal, I'll invoke R. I'll go back to the script file and copy the entire file. I'll paste it into the terminal where R was invoked. When the graphics parameter is reached, execution is halted, waiting for user input. A graphics terminal is open, which I'll move out of the way. After the input is supplied, a graph appears. These are the wireless devices detected at my house. My D-Link router is unencrypted. The strength of each router is expressed in dBms. One can see the signal strength of the routers are all around -200 dBms. The same procedure produces the wireless access points at GSK. At Central High School, amazing at the exceptional coverage. I am also amazed at the quantity of public access. At Timberlane Middle School, and finally at the administration building. The wireless coverage at the high school, the middle school, and the administration building are much more pervasive than the wireless coverage at GlaxoSmithKline. Is the public access so abundant because students are expected to possess personal laptops, or because many contractors are expected? Is the Hopewell Valley wireless access so abundant because the district determined that laptops facilitate education better than desktops? Have the plans to purchase the cart of laptops changed? The laptop I'm currently using has Linux installed. It is 6 years old. Will the school district ever begin to consider cost-effective solutions? When I expressed my confusion during my demonstration, Patricia Coates claimed the plans to utilize the wireless access have yet to be developed.